Okay, these new set of slides discuss monitoring on FutureGrid, and we've already stressed that if you have a test bed, you better have great monitoring and great metrics, because there can be a lot of users whose goal is to do monitoring, because they're doing testing, they're reporting performance, and possibly reporting robustness and reliability and things like that. So here's our composite of the four major monitoring environments: Inca, Ganglia, Snap, and Persona, doing software functionality, cluster monitoring, network, and a couple of types of measurements, LPerf and SNMP, and those are all done on FutureGrid and reported on the FutureGrid websites. So we think we've already stressed that the feature of FutureGrid is you know what you're doing. And given that you know what you're doing, you better be able to monitor it and report what you're doing. And here we have Nimbus and Ganglia providing information, which is you can use to see what happens to the load on your nodes and things like that, and what is the status, the actual images that you have in your environment, because you can have an image and it may not actually be running. So these are distinct monitoring capabilities. We have developed at Texas a messaging environment which allows us to accumulate and put into a database all this performance information. And then we have a dashboard, a user interface that allows you to access it. It happens to use CouchDB, which is a well-known NoSQL object store for storing it, and uses a very well-known, excellent messaging system, RabbitMQ, which uses the standard AMQP format to do the messaging. So here's some notes about some of the work at Tennessee on PAPI, performance measurement. And one of the troubles is these virtual machines do not come with the same, although you virtualize most things, you haven't always virtualized the performance counters. And so it's not so trivial to take standard performance tools, which PAPI supports, and use them in virtual machines. And as is stressed here, the VMs may not expose the hardware counters. That's gradually getting better. All of this is partly the immaturity of the environments. Another important issue we see, of course, we've already mentioned with network cards. Virtualization is done using software to emulate the hardware. That software can have significant overheads. So you need to carefully take that into account in your environment. And these overheads are particularly important in things like cache events and TLB events. So there are various ways of doing timekeeping. Tickless timekeeping with no interrupts is the best. PAPI has two types of timing routines: war club time and virtual time. And the virtual time is affected by the time when a virtual machine is descheduled on a busy environment. And PAPI has already implemented the ability to correct for this descheduling on KVM, which is important for loaded virtual machines. That's illustrated on this slide here, the effect of the steal time. Here we have non-virtualized environment. We have the real wall clock time, and here we get the time. These are matrix multiplies, so it should be a fixed time. So this is the time for the matrix multiply. As a function of the number of other things running on your system. And here we do not. Here we have a stealing event, and that stealing effect here, where what you naively report is actually just the time to run the matrix multiply, not the virtual time, which should run along here. That is because the stealing is not properly corrected for. So that needs to be put into environments like PAPI with the current virtual machine systems we have. Here we have the last section of this MOOC on FutureGrid appliances. Appliances are very, very important because you could say they are the heart of cloud technology, or as far as the user is concerned, because appliances mean an image with everything you possibly want. Your OS, your user code, your virtual network, your multiple images. That's what appliances are. They're everything. They're particularly important for education and training because appliances can be used to capture a piece of software, and that same appliance can be run on your VirtualBox, on your client, or on FutureGrid. We have developed and made available for people to test Condor, MPI, Hadoop, and iterative MapReduce appliances. So the general idea is a system like FutureGrid is a natural platform for programming labs. And so you want to have these appliances so people can just use them. If you have a lab involving Hadoop, then the Hadoop appliance is what you want to use to execute. And we also want to accumulate appliances from lots of different people. And as we discussed, these appliances are actually deployable not just on FutureGrid, but as we sort of discussed with Cloud Mesh, they can be deployed on other platforms. Currently, we actually make the appliances separately for each platform. In the future, we can probably use Cloud Mesh to make that deployment of appliances across different IaaS approaches in a more seamless fashion. We have grid appliances on FutureGrid. It captures MPI, Hadoop, or Condor. We have same image for each node. We have the Vine virtual network to form a cluster. And you can deploy this any way you like. You can deploy it on a distributed environment, on a localized environment, and so on. Put it on your client. Because everything is virtualized. You get your virtual grid. You can put where you want, which is probably not terribly useful for production work, but it is highly useful for education. That's why we stressed education here with these integrated appliances, which have everything you need to build an environment. Here's the last slide of this particular MOOC on grid appliances. And it just illustrates with Hadoop and a virtual network how this works. You have your Hadoop workers, which you instantiate. These are your virtual machines, which you just copy. Your appliance is just downloaded from a library. Then you need to get some credentials where there's some technology, virtual private network technology to describe a group of, say, students who can use this cluster. And then you get these virtual IP addresses, and that's it. So that shows the components, the virtual network, the credentials, and the customized pieces of software, which give you, in this case, your Hadoop appliance. Thank you very much. This is the end of my detailed discussion of FutureGrid, which is available as an expansion on the overview, which is also recorded and available. Thank you very much. This is Geoffrey Fox signing off for the FutureGrid team. Thank you.